Thank you. So this is single-page apps, what an API developer should know. I am here to bring you a message from front-end land that things are different here. I spent over 10 years as a back-end developer and about 8 months this year as the manager for a front-end engineering team building an Angular app. There were a lot of things that I had to wrap my head around in order to be able to successfully design a product that I think API developers should know more widely. So that's what this talk is about. So you should listen to this talk if you're a builder of particularly read and write APIs or APIs which power client applications. So why should you learn more about SPAs as an API developer? The first topic is architecture. Another one is security. And there are some particular challenges around teams and how you do your engineering process and your communication. So we'll talk a bit about those. And of course, your choice of stack. Do you want to be developing a single page app? Is it the right choice for you? So I'd like to do a quick couple of polls. Can you raise your hand if you've ever developed a single page app? Okay, I think we have about 4 people. All right. Now I'd like everybody to raise their hand. Okay. So leave your hand up if you've ever written an API. Okay. Leave your hand up if you've ever written an API that backs a single page app. Okay, we're down to maybe 10 people. You've written an API that backs a single page app that has user login functionality. Okay, I think we have 3. Oh, and a 4th over there. All right, has anybody written an API platform that backs multiple different single page apps with user logins? Oh, great, awesome. We got a couple pros over there. All right, so you guys probably already know what I'm going to talk about, but we'll go on. So as I already mentioned, we're going to talk about single page app architecture, a little overview for those of you who are less familiar. We're going to talk about security, state management in your application, what it really means that a single page app is static, some options for backends to single page apps, and then finish up with the whole why I care about this. So for architecture, it's hard to be a developer these days and not have heard of Angular, Vue, React, or Ember. Those are really the big single page app frameworks. These are mostly pretty similar, although Vue and React offer some server-side rendering or isomorphic JavaScript support. That muddies the water a bit, but for the most part, these are similar. So if we talk about more, let's say, traditional app development, server-side rendering versus client-side rendering, that's really the highest level difference that you need to worry about. Whether your server is prepping the HTML and sending it out to the client on every request, or whether that's kind of happening client-side. So a single page app, the very first request brings down the bundle of HTML, CSS, and JavaScript, and then pretty much all your subsequent requests are going to be just data only and done via APIs on the back end. And we'll see this illustrated in the next slide. So at the top, you have the traditional page lifecycle, requests coming in on the left from the client. Request goes to the server sends back HTML. You have another request, this time it's a form post. Server sends back HTML. So below that, you have the single page app lifecycle. Request comes in from the client on the left, hits the server, sends back HTML, but that's really the big bundle of the single page app being downloaded the first time. And then another request, that one is going to be AJAX coming out of the single page app and JSON coming back. So one key part of really understanding and coming to grips with how different single page apps are is that you can deploy them entirely statically in an S3 bucket. When I was working on a project with a single page app, this was one of the hardest things for other developers to understand. I had to spend a lot of time explaining to our DevOps team why we didn't need any really complicated continuous deployment pipelines or monitoring because our code was going to be in an S3 bucket. But it also had ramifications for sort of how we thought about how we did security, how certain middleware layers were going to make sure that people were passing the right security tokens through and so on. And I'll be elaborating on the ramifications of this for the rest of the talk. So a standard single page app only has a single route on the server. And I think my slide's a little bit out of order. So your single page app is just probably hosted at your root domain name, whatever yoursite.com is. And that's the place where a client's browser request is going to go and download the bundle of your single page app. But the telltale sign of a single page app is usually the hashtag in the URL. So the hashtag is the indication that JavaScript is doing the routing and essentially building up the pages for everything after that. So now let's talk a bit about security. So you can never trust your client code. There's really no way once that single page app bundle goes out to the world that you can make sure that nobody has tampered with the code. So that's the most important point here. And then what that means for API developers is that you're responsible for security in the API. All of the authentication actually belongs to the user. You can't keep secrets in a single page app. The user's own knowledge of their username and password are basically all you get in terms of security. So user will enter their username and password. After they are authenticated, they'll get a security or a session token, and then that's going to be what's passed back to your API in most situations. So your API in this case is also responsible for authorization. You can only trust the user. You can't trust the client. You can't trust the session key either for authorization because there are things that can happen, which I'll talk about in a second. So your API that's backing a single page app always needs to double check permissions. Stating this another way, permissions belong to the user object and don't rely on just session keys. So you want to authorize in real time for anything that needs elevated permissions in your backend or does destructive actions. Things can happen in real time that make sessions or permissions invalid, such as a user's account entering fraud status or somebody making an attempt to break into a, too many failed password attempts or something on their account. So your API needs to always be checking So this is one of the trickiest things. So if you are building an API platform, it's probably going to have multiple clients access it. So say you have different clients to service different industry verticals. One could be, since we're at Capital One, say one's for banking, one is for the DMV. A given user can authorize a client on their account, using three-legged OAuth. But a malicious user can abuse those privileges to perform actions that are not supposed to happen from that client. How do you differentiate the users and their permissions per client if you can't trust the client? One option is forcing multiple user accounts for different permissions, so you push it back to the user. They have to have a different set of credentials, but that kind of defeats the purpose of your identity platform. I don't have a great answer to this. It's just kind of a problem in single-page app land. A final note on single-page app security. In addition to the user's auth token, your API needs to support XSRF tokens to prevent against cross-site scripting attacks. This is something people often overlook as well. And I found this great quote from a really good article on single-page apps and why they need cross-site scripting protections. So if tokens aren't enough, why do so many public APIs only provide token-based authentication? Probably because the primary use case for these APIs isn't to be consumed directly by a JavaScript client in a web browser. Are you sure your apps are so secure? Okay, so I'd like to talk a little bit about state. Your API is probably not a museum, although I have worked on many a read-only API myself, having been in the open government space. A lot of apps that just serve up kind of canonical data are, read-only APIs. So this is kind of an attitude that I had brought to the work. But most likely, if you're interested in this talk, your API is more like a bazaar. It needs to be able to save state and possibly transactional histories, maybe have object versioning, audit logs, etc. Another quick poll. Raise your hand if you develop read-only APIs. Wow, nobody. Okay, good. So something that people often struggle with in this sort of development is that client state, of course, can't persist across sessions or devices. It's kind of a sort of a duh thing to think about, but it gets overlooked occasionally, especially when the API team and the front-end team are have competing priorities, and maybe there's a new piece of data you need to save and the API doesn't have the capability to save it yet. So there are considerations around that. And just to say again, your API is really not a museum. You need to think carefully about how client interactions should or should not change your core data. A lot of times API developers have these sort of grand ideas about how their data schema works and what their REST API structure is like, but they're not as prepared to do things like represent client state in their API. And you might need to think about how you do that in other models or other microservices, et cetera. Once you have a client-side single-page app in play, UX really becomes important. to how you think about the persistence and refresh of data. You need to consider what data may change in your API that the user needs to know about or the app needs to respond to. How will the user get that data? Unless you're implementing WebSockets, updates will be based on polling or strategically timed refreshes. Some data can be fetched and persisted at login, others with each page load, and others may need to be after more granular interactions by the user. This is also another hard thing for API developers to understand, which is that modern JS frameworks are built on the idea that the client app is independent. This is especially true under the React and Redux or RxJS model, but those single-page apps are really implementing an independent data store and data model inside their own application. So what does that mean? Well, the API's data model may be similar to, but not identical to, what the client needs. As a result, getting data out of the API is easy, but getting it back in will often be harder because objects that are transformed for display in the client will need to be transformed back or untransformed to be persisted back into the API. And what that means for your development team is that every time the schema of X changes in your API, Y in the client may need to change its schema as well. So a tip here is to really talk to your front end or Edge API developers here, because their experience building your data model into a client can inform a better API design. So the upshot of being static, what does it all mean? So at this point in the talk, I want to look at the ramifications of all these things. Just to review, a URL refers to the whole of a single page app. Any URL referring to something inside the app beyond the front page is called a deep link. Deep linking is possible but often tricky or annoying to implement for the front-end devs because single-page apps are often built for people to come sort of in the front door of the application. Single-page apps are static, plus logic and Ajax. So that means that your API layer is now exposed to the world. Your API can't hide behind server-side rendering like it did with server-side application development. Another thing is that all of your experiences for the client must be baked into it in the first place. You can't really push a new experience or flow to the user based on data, circumstance, or state. It has to be there from the beginning. And by extension of that, sensitive data must be preserved in the API. Data you might not think of as sensitive, but which is data which a given user might not be privy to, needs to be held on the server side. So an example of that might be things around terms and conditions or certain even error states. You might think that it's simple just to code all of your error states into your application, but you might not want to reveal all of your possible error states to the world. So this harkens back to the security portion of this talk. Separating business logic and all possible permutations of that, as well as sensitive data, requires a different way of thinking than you may be used to. So there are some back-end solutions that can help smooth some of these difficulties over. A pretty popular one is writing Edge APIs I mentioned exposing your API to the world. Well, an edge layer sits in front of your key APIs. And what it will do is expose, proxy, and orchestrate your API endpoints. So if there's particular REST API resources that may be very pure, for instance, so you have related resources, there may be a number of API calls that need to be made all at once in order to render a particular page of a single page app. An Edge API can kind of create a shortcut for you to be able to pull all the data that you need in one view at one time. Edge APIs can also hold credentials for specific clients, although you need to be careful with this, or other APIs that you don't own within your same enterprise or externally. And then the reason I said be careful about specific clients is that it's still possible for a rogue client to abuse an edge beyond its intended purpose. So you have to be careful about that. Another thing which muddies the single page app waters a little bit is that some of the other frameworks like Vue and React do support a form of server-side rendering. They help with search engine optimization, some performance issues. On the other hand, they don't really help with the security concerns that I've outlined, nor with the state issues. So why should you bother to understand all of this? Well, first of all, if you need to make architectural decisions, knowing better how single page apps works helps you select your stack, determine your overall architecture, determine your API's request and schema architecture. It helps determine your authentication, your security. And you should really know what you're building. It's important when you're working with single page apps for your API team to kind of have some guiding principles figured out beforehand for how you want things to work. Have your team live by them, although iterating is needed. So some questions you want to consider are which parts of your API are general purpose? The flip side of that is which ones are tailored to a given client experience? Where do those two things overlap? And what data do you need to protect? Another concern is API versioning. When you're building an API to a client, coupling between the API and the client can become very tight. API versioning, of course, is kind of a contentious topic. Versioning in headers versus URLs is something a certain subset of devs likes to argue about. I would propose that for maximum agility and least code debt and not having to support multiple versions in both backend and client code, that you consider an additive-only approach, sort of like when you're designing a good database migration, if you're familiar with those. So backwards incompatible changes must be made to new endpoints, and old endpoints must only be removed if no one is using them anymore. And in case I didn't harp on it enough, just a reminder that we really have to understand how single page apps function in order to properly secure our apps. I have a suspicion that the world is probably full of insecure single page apps and consequently insecure APIs. So some things that kind of happen when you're developing single page apps, it's really easy for your teams to fall into functional silos because of the extent to which the stack is separated. So I'd like to propose some considerations to counteract functional silos. I said the word client a bunch in this talk, and I was using it in the computing sense of a piece of software which acts as a server. But I'd like to propose an alternate way to think about that. The front-end team is your client. Their needs will drive much of what you build. Listen to them very carefully. If you have a front-end lead, they may be your de facto solutions architect. This was actually the role that I played on this team because the person who needs everything in the client to work also needs everything all the way through to the back end to work. Try to focus your communication around verticals. So when you fall into functional silos, they're probably horizontal silos by team and by front end, back end stack. In that case, it becomes more important to communicate around features. So try to direct your teams around understanding really front to back how what they're building is going to work. And pictures and diagrams. Interaction models with single page apps tend to be really complicated at times. Draw sequence diagrams, they really, really help. So, hey, API developers, yes, this talk is about you. It's about all of us working better together. You should understand single page apps for making better architectural decisions, having better security, better state management, and better engineering process management. And thank you, and happy building. Also, my team is hiring. See. Any questions?
I was wondering if you could talk about some of the trade-offs between a single-page application and just a traditional rendering application for some sort of really data-driven like application that you're going to construct.
Yeah, well, I think some things you need to think about are, again, having UX drive some of those decisions. For something that you need to be truly real-time, responsive, interactive, a single-page app may be a great way to go. But personally, I think that the world has kind of rushed a little bit too much in that direction. For data-heavy applications, I think it's good to render things server-side and then provide AJAX to speed up certain interactions. Yeah.
Okay, that's it. Can we give a big round of applause then to the speaker? Thank you.